This is part 2 of lecture number 5. In this part, I will cover exception handling. I will open lecture 5 exception.py and I will set the breakpoints. I will start debugging. So, what is exception handling? When an error occurs, or exception as we call it, Python will normally stop and generate an error message. These exceptions can be handled using try statement. We do not want our code to stop or exit. Rather, if an error occurs, we want it to go to certain code that handles that error that we will cover in this lecture. The concept here is try and accept. If we can foresee that certain code will crash during execution, we will put that code between try and accept. For example, here I have written x is equal to 10. I am printing x, and then in the exception part, I am printing an exception occurred. So in this part of code, no error is occurring. It will execute normally. So 10 is x is equal to 10. We try that we print x value is printed, hence exception part is ignored. Now we move to the next try and accept. But before going further, let me change the previous code so that we see that some error occurs. X is equal to 10 divided by 0. So I run or I debug the code again. X is equal to 10. I print the value of x and then I divide 10 by 0. So you can see that division of any number by 0 is mathematical error. Hence, the system sent the processor to accept part. Now, the code existing in the accept part will run. So, it will say that an exception occurred. In the next example, covered from line number 13 to 18, the difference here is that at the end I have added the else part. So, first it will print, after that, it will print else part, meaning that if exception occurred, else will not be executed because else is in contrast to accept. Whereas I have written a word finally here. Finally is a part that will execute it for sure, even if the normal execution happens or the exception execution happens. So I'm printing x, that was 10. So the normal execution happened, and then finally the try except is finished, is executed. In the example covered in line number 21 to 26, the concept is that finally will always be executed. Whereas in the example covered from line number 13 to 18, else will be executed if code runs normally. If any exception happens, the else part will not be executed. Now on line number 29, we are covering nested try except. In this example, if any error happens in the first try, the except part of the first try will be executed. Whereas if any error happens in the second part of the try, in the nested part of the try, the nested except will be executed. So when I execute line number 38, it has moved to the first except part because the demo file.txt is not existing in our folder. Hence, the first except part is executed. And you can see that it is printing something went wrong when opening the file. Now let me create the file and we will rerun this program again. Now as we already have this file demo file.txt, when I try to open the file, it has opened. So the first accept part is not executed this time. Now I'm trying to write some text into the file, but the computer was not able to write the text in the file. So the internal accept part is executed, and finally the file is closed. But you can see here that the external accept part was not executed. In the next example, I'm throwing an exception in my try code, meaning that I'm intentionally trying to execute the exception part of the code. Whereas in this except part, you can see that I have created an object E of type exception. All the exceptions that happen in Python can be classified as exception and are covered in the exception class. So when we create object of this class, we can get details of the exception. So now I'm throwing an exception. The exception is related to not implemented error. So you can see that no error, that was the intended message, is passed to this E variable. Whereas in normal scenario, we want to get details of the exception. So I'm throwing the exception again and I am importing some inbuilt modules, system and OS. These will be used to get the detail of the exception. What detail will be shown? Let us check. You can see that no implement error type of the exception was created in the file number lecture 5 except at line number 52. So using this code, I'm not only able to know what type of exception happened, but I was also able to check which in which file it happened and at what line number it happened. So sometime you observe that application send error report to the server or to the company, but the application do not crash, meaning that rather than exiting, it simply gives you a message that something has happened. Let me report to the server, and it restarts the operation or restarts that specific module. They simply send exception related data to the server. This helps the programmer to identify what error happened at what line number. Similarly, you can track in your code where the error happened and what type of error happened at that specific instant. This concludes our lecture.